Welcome to Module 1, Tox-free, Circular, and Climate-Friendly Buildings. In this part, we explore how buildings influence both human health and the environment, often in ways we don't immediately see. In Module 1, we cover 4 key topics. First, how buildings affect health and the environment. Second, the role of municipal leadership. Third, the connection between hazardous substances, circularity, and climate. And finally, 10 essential facts about construction materials and their health impacts. Let's begin with Section 1.1, the impact of buildings on health and the environment. Buildings are major environmental players. Over their life cycle, they account for around 40% of greenhouse gas emissions in the European Union. A third of this comes from energy use, with an additional 5 to 12% from the production of materials and construction. Buildings also store hundreds of millions of tons of materials, and the construction and demolition sector generates the largest waste stream in Europe, nearly 500 million tons every year. Finally, many building products release chemicals that can wash off with rainwater and enter soil and water systems, creating long-term environmental pressure. Buildings shape far more than the skylines of our cities. They affect outdoor air, indoor air, and the ecosystems around them. Volatile organic compounds from paints and coatings contribute to outdoor air pollution. Formaldehyde from composite wood products compromises indoor air quality and can contaminate surrounding soil and water. Extraction of materials and production processes often rely on resource-intensive and environmentally damaging methods. Altogether, the material choices made in buildings create a chemical footprint that lasts for decades. Once harmful substances are built into a structure, they can remain there for decades. Insulation, coatings, and various finishing materials can slowly release chemicals over time. Even after demolition, these substances may continue to leak into soil, water, or the air. Volatile organic compounds can evaporate for years, and persistent pollutants can contaminate recycling streams, making safe circularity more difficult. Toxic substances in building materials also have direct impacts on human health. VOCs, dust, and fibers can irritate airways and contribute to chronic respiratory problems. Some additives, such as phthalates and certain flame retardants, can disrupt hormonal systems. Others, including formaldehyde and silica dust, are linked to cancer. Children, pregnant women, and older people are particularly vulnerable, and they often spend more time indoors. Other impacts include skin and eye irritation caused by solvents, adhesives, and paints. Exposure to heavy metals found in older materials can influence neurological development. And mold-prone materials, VOCs, and chemical additives can trigger allergies or asthma symptoms. Indoor environments matter, and poor materials can make indoor spaces harmful. So, why are hazardous substances still so widespread in construction materials? The answer lies in performance. Our expectations for buildings are higher than ever. Clean facades, dirt-repellent surfaces, and strict fire safety requirements. To achieve these, manufacturers add chemicals such as biocides, PFAS, bisphenols, and flame retardants. These additives deliver convenience and durability, but at a cost to health and the environment. Within a building, certain areas become hotspots for toxicity, embodied emissions, heat loss, or circularity challenges. For example, wet rooms often require materials that impact both toxicity and circularity. Understanding where these hotspots occur helps designers, builders, and municipalities take preventive action by choosing safer materials and planning for maintenance and reuse. The most critical toxicity hotspots are large surface areas, walls, ceilings, and floors, where paints, varnishes, and PVC flooring release volatile organic compounds. Adhesives and sealants are another concern, as they emit harmful chemicals. Carpets treated with stain-repellent coatings may contain PFAS, the so-called forever chemicals. Good ventilation is essential to reduce exposure and maintain healthy indoor air. Real-world exposure doesn't happen one chemical at a time. We are exposed to mixtures, chemical cocktails, and their combined effects are often poorly understood. For hormone-disrupting chemicals, there is no safe threshold, and additive effects should guide regulation. Studies show that even very low levels can cause harm when multiple substances interact. This is where the precautionary principle becomes crucial. The structure of a building, its concrete, steel, or timber frame, is usually the largest source of embodied emissions, sometimes up to 80%. Avoiding unnecessary surface treatments helps reduce both toxicity and future waste problems. Heat loss hotspots occur in the building envelope, insulation, airtightness, windows, and doors. Where different building elements meet, such as corners or balcony edges, detailed planning and modeling are essential. Circularity depends on how materials are selected and assembled. Hotspots appear where layers are fused together, making disassembly difficult. Areas with heavy material use also require careful planning to ensure that reuse or recycling pathways exist. Glued insulation on structural elements, for example, can block the circular potential of both materials. Typical hazardous substances in construction include PFAS, brominated and organophosphate flame retardants, biocides, and volatile organic compounds. Each group brings specific risks for human health and ecosystems. PFAS, often called forever chemicals, include more than 10,000 compounds. They are highly persistent, mobile, and can bioaccumulate in living organisms. Some PFAS are linked to endocrine disruption, reproductive harm, and cancer. Their water and stain-repellent properties have made them common in textiles, flooring, insulation, paints, coatings, and sealants. Brominated flame retardants are used to reduce flammability in plastics, foams, and finishing materials. However, many are persistent, mobile, and toxic. Some are carcinogenic or endocrine disrupting, and residues are found globally, even in remote areas. Despite restrictions, these substances often remain in recycled materials. Organophosphate flame retardants are used as substitutes for some restricted brominated compounds. They function both as flame retardants and plasticizers and are commonly found in PVC, polyurethane foams, and insulation materials. But they pose their own risks, including neurotoxicity, developmental and reproductive harm, and endocrine disruption. They are widely detected in indoor air, dust, soil, water, and even in humans. Biocides protect materials from mold and microbial degradation. They are commonly used in paints, coatings, sealants, adhesives, wood products, and natural fiber insulation. Because they are designed to kill living organisms, they are hazardous to humans and the environment. Many biocides are harmful to aquatic life and can affect indoor air quality through off-gassing. Volatile organic compounds evaporate easily at room temperature and are found in a wide range of construction materials, including paints, sealants, flooring, and insulation. VOCs contribute to respiratory issues, allergies, cardiovascular stress, and in some cases, cancer. They also degrade outdoor air quality when they form ground-level ozone. Choosing low VOC or VOC-free products significantly reduces exposure. To support safer decision-making, the Building Material Catalog provides detailed information on hazardous substances in common materials. The NHC3 fact sheets offer practical guidance linking chemical safety with circularity and energy efficiency. Thank you for listening. To explore more resources, tools, and guidance, visit the NonHazCity 3 project page under Interreg Baltic Sea region.